Welcome back to the MCP Workshop series. We've covered data and AI. Now it's time for the third pillar, APIs. APIs are what makes systems talk to each other. And if you want AI to interact with the real world, with your BIM data, with project management tools, your cloud storage, APIs are the bridge. So, what exactly is an API? An API, or Application Programming Interface, is a contract between two software systems. It defines how one system can request data or trigger actions in another. There are four key characteristics. First, define endpoints. These are URLs that identify specific resources. For example, a URL like /projects/123 points to a specific project. Second, structure requests and response format. APIs typically use JSON, which is a lightweight way to represent data as key value pairs. Third, authentication via API keys or tokens. You need credentials to prove you're allowed to access the system. And fourth, APIs are documented and versioned. There is a specification that tells you exactly what you can do and how to do it. Let's break down how an API actually works. The core elements are the endpoint, which is the URL that identifies the resource, the method, which is the action you want to perform, get to read, post to create, put to update, delete to remove, the headers, which carry metadata like authentication tokens and content type, and the body, which is the payload for post or put requests. The cycle goes like this. The client sends a request to a specific endpoint, for example, get/project/123. The server processes the request, accesses its database or logic, and then the server returns a structured response with the status code and the requested data. This is the foundation of how every modern web service works. Your browser does this thousands of times a day. Now, here's where things get interesting and where we start to see why MCP exists. APIs are powerful, but they have a fundamental weakness when it comes to AI, the N times M problem. Without a standard, connecting N AI models to M tools requires N times M custom integrations. Each one is built from scratch, maintained independently, and needs updating where either side changes. Let's say you have 3 AI models, Claude, ChatGPT, and Gemini, and you want to connect them to 4 tools, Google Drive, GitHub, Slack, and Revit. That's 3 times 4, 12 custom adapters you need to build and maintain. The result is that integration cost grows exponentially, not linearly. Every new model or tool multiplies the work. And in a fast-moving field like AI, where new models and tools appear every month, this becomes unsustainable very quickly. There is another limitation. Traditional APIs are static by design. Each capability requires a dedicated endpoint. Adding feature means modifying the server and updating all clients. And the client must know in advance what the API can do. For traditional software, this is fine. You build an integration once, it works, you move on. But for AI, this is a real problem. The LLM cannot discover new capabilities at runtime. It can only use what was told about upfront. Every tool change requires rewriting, integration code, and there is no flexibility to adapt unforeseen use cases. APIs are powerful for structured, predictable workflows, but they struggle with the dynamic, open-ended nature of AI agents. An AI agent needs to be able to ask what tools are available and then decide which ones to use based on the task at hand. Traditional APIs simply don't support that pattern. Let me give you 3 concrete examples of APIs that are relevant to what we're building. First, Autodesk Platform Services, or APS. This is the API layer that lets you access BIM data, manage files, and translate models. It provides RESTful endpoints for data management, model derivative, and ACC. Second, the LLM Provider APIs, OpenAI, Anthropic, and Gemini. These let you send prompts and receive completions. They use a fixed request format with a model, messages, and parameters. Third, the ACC API specifically, which let you retrieve issues, RFIs, and project members, and automate workflows across the construction lifecycle. All three of these are well-designed, well-documented APIs, but each one requires separate custom integration. If you want an AI agent that can talk to all three, you need to build 3 different connectors, handle 3 different authentication flows, and manage 3 different response formats. This is exactly the problem that MCP was designed to solve. So, that's the API pillar. APIs are essential. They're how systems communicate. But when it comes to AI, their static nature and the N times M integration problem create real friction. Next time, we tackle the 4th and final pillar, MCP. We'll see how the Model Context Protocol creates a universal standard for AI to tool communication and how it solves every limitation we just discussed. Leave your questions in the comment and I'll see you for the next one.